Today, I would like to talk to you about the Container Operator's Manual. And if you have any comments, critique, feedback, want to talk about how rad these pants are, I found them last week, thank you. You can send me a tweet at Alice Goldfuss right there. And let's get started. But first, let's talk about who am I? Well, I'm Alice. Nice to meet you. I am a site reliability engineer at GitHub, which means I'm a professional warrior with pseudo access. And today I want to talk to you about car ads. Now, you know when you're watching TV, and by that I mean you know the 5 seconds you have to wait until the skip ad button comes up on YouTube, and it opens up in this beautiful, picturesque mountainside with this serpentine trail weaving in and out, and there's this sleek beast of a car just swerving down, and as it's raging through the countryside, there's all these stats that are popping up, like 0 to 50 in 10 seconds, and 70 miles to the gallon, and 5-star rating, and you're sitting there like, yes, science has proven this is the perfect car. If I buy this car, I will have achieved perfection. And if you pay attention, at the bottom of the screen, in really small letters, you may see the phrase laboratory setting. Laboratory setting. Because it's a car ad. And all of those magnificent scientific stats and figures that you saw were actually obtained in perfectly tuned laboratory conditions and are really just one step away from theory. And if you were to actually purchase that car and take it out in the field, you would get much different results. And that's how I feel about most container talks. You go into a container talk, presenter comes out and it's like, bam, stop right there, sit right there. In the next 20 minutes, I will tell you everything you need to know to completely revolutionize your infrastructure and how to run your apps in containers. What's that? You want to run more than one container? Well, no problem. Just download this gist, don't read it, run it on your laptop, and in 5 seconds you will have a perfectly tuned 3-node cluster running in perfect synchronicity right on your laptop. And what's that? You want to run containers in prod? Well, go right ahead. After all, prod is just your laptop times 100, right? Okay, great. And then they walk off. And you're left sitting there at this half-finished tutorial going, is this why sysadmins are so mad? Personally, I would like to see a lot less Docker 101s and a lot more Docker what the fucks. Because there are just some things as an industry that we need to talk about when it comes to containers. And that's all I want to do with you here today. Just talk about some of the pros and cons so we can make a better decision about containers. And you might say, yeah, that sounds great, but why should I listen to you, Edward DevOps Hands? Well, I've been running containers at scale in production since January of 2015. And if you consider the fact, so that's like about almost 4 years of running at scale containers. And if you consider the fact that Docker came out about 5.5 years ago, that's pretty good. In fact, the company that I was introduced to containers at looked at Docker 0.6 and were like, yeah, run it in prod. So we did. And then we literally paved the road behind us trying to figure that out. So that was a lot of great early adopter experience. And from there, I went to a team that ran Dockerized Cassandra clusters. And now I'm on the team that owns the Kubernetes platform behind GitHub.com. So I have a little bit of idea of what I am talking about, and I just want to talk about it with you. But before we start, just to make sure we're all on the same page, let's cover what is a container. Because if you've ever been to one of those Container 101 talks, it probably goes a little something like this. First, you have your host, and it's a box. And on top of your host, you have an operating system, which is also a box. And on top of your operating system, you have your container daemon or engine, and it's a box. And then on top of that, you have your containers, which are smaller boxes. And that's great. Except it's lies. It's just completely lies. This may be how humans see containers, but this is how your computer sees containers. This is the top readout from a production Kubernetes server about some processes that are running on it. So let's take a look here. So third down, we have the Docker D process, which is that Docker daemon, that container engine. Fifth down, we have the kubelet process, which is the Kubernetes process. And then we have some Python and Ruby processes. And those Python and Ruby processes are containers. Those are containerized applications, and they're not abstracted away. They're not hidden in boxes. They are processes because that's all containers are. Containers are processes born from tarballs, anchored to namespaces, and controlled by C groups. So now you know. Let's break that down a little bit. What do I mean when I say that containers are processes? Well, containers as a concept don't exist in the Linux kernel. There's no like compile kernel -f container. Like, there's no flag for it. It doesn't know what that is. Containers are just a bunch of native Linux features stapled together, and then people go, ta-da, it's a container. So when you are making a Docker file or some sort of container config, you are specifying a recipe or an instruction set for the environment and file structure of your application. And then when you build it, you're putting it into a tarball. And then when you deploy that and make an image, the other way around. When you're deploying that image into a container, that tarball is being unpacked and run as a process, like any other process on that host. And here's where those native features come in. The first one being namespaces. Namespaces determine what a process can see, like other processes or directories, just a slice of the universe, not everything. And it thinks that it's everything, but it's not. And then we also have C groups or control groups, and those determine what a process can use. Resources like memory or CPUs. And together, these make a container. This is a container. Nice. And if you're thinking, oh, I don't know about that. I thought it was just like whales. Don't worry. We're going to take a nice, hard look at what it means to run containers at scale in prod. And I will say that the majority of my experience comes from running on-prem hardware, not in the cloud. I know things are a little differently there. But just because you think it doesn't apply to you doesn't mean that you can throw away all my suggestions. This isn't the Linux kernel mailing list. So we are going to be going through 4 lessons. It could have been way more than 4, but just 4 lessons to give you a better sense of whether or not containers are right for you. So let's kick it off right out the bat with containers have strengths. I don't want you leaving here being like, that ska kid doesn't like containers. I like containers, okay? But you have to use them for the right purposes. You have to play to their strengths. And containers' strengths lie in stateless applications. Now again, just so we're all on the same page, what is a stateless application? A stateless application is an application that takes data in, changes it in some way, and then sends that changed data out. And it doesn't keep anything for itself. The application itself is not changed by that data. It doesn't tick a counter. It doesn't do anything. It doesn't care. It just moves data in, changes it, moves it out. And stateless apps are fantastic for scaling out your services, because you have a bunch of them running right alongside each other, intaking from the same dependencies, outputting to the same dependencies, and if one of those instances goes down, your dependencies don't care. They're still sending data and receiving data. And the other instances also don't care, provided you have headroom, because they don't care about each other. They are stateless. They are these ephemeral, disposable things, just like containers. And so if you have places in your infrastructure where things are already stateless, like microservices, whatever that even means, I strongly suggest you put them into containers because that will maximize the strengths of those already stateless apps. And just as a reminder, containers are not magic boxes. My magic boxes are okay because we know they're lies. But in general, not actually boxes. So, okay. What are the strengths that you can bring out by containerizing something? Well, first of all, you can make them portable. Once you go through that painstaking journey of delineating each dependency your application needs to run, as long as you have a kernel that'll run your container, you can run that application. It's fine. You don't have to worry about unforeseen circumstances, which means that it is so much easier to upgrade. You can just bump your code, rebuild it, deploy it, and you don't have to worry about something not finding a path or not being there anymore, which also means you can iterate a lot faster. You want to try something? Cool. Try it. Try a new library. Try a new code path. Try a new circuit breaker. Build it, deploy it. If it fails, you don't even have to do a rollback. You just have to deploy the previously built image. You're done. Now, you can get that information from a blog post. You can get it from one of those Container 101 talks. But a strength you're not going to see talked about in a blog post or in a Container 101 talk is disaster recovery. Who here has had to deal with disaster recovery? Ah, yes. For me, it's Twitter. But once you get to the point where you're hearing words like legacy or SOC 2, you probably have to do disaster recovery. And how many people here have done a disaster recovery exercise that looked a little like this? Yep. You're getting ready to redeploy your architecture in a fit amount of time, and it turns out that this application uses Capistrano, this one uses Jenkins, this one is run on a cron job on someone's laptop every day at 3 a.m., and if they were to quit, we'd be in big trouble, theoretically speaking. And they're all different. And then the day of the disaster recovery exercise, you're like, oh yeah, I thought I knew how this worked because the developer wrote up documentation, but it turns out not even they knew what they were doing, so now I need to find them or someone from their team to come sit with me and actually deploy their application, and now everything is so much slower and terrible, and Twitter is on fire, and that's fine, honestly, but we are not fine. But if everything is in containers, that means your apps are being deployed the same way to the same place. And as someone who has been on the Capistrano and container side of a disaster recovery exercise, I much prefer it over here. It goes so much faster. This is also great for outage recovery and on-call. So like old way, something breaks, you get paged, you wake up, you look and you go, actually, that's not my service. It's this other team's service. So now you have to page them and wake them up, and then they have to look at it and try redeploying it and fixing it, and it's this long thing. But if everything is containerized, you get paged, you wake up, you say, that's not my service. It's this other team's, but we all use the same deployment pipeline, the same containers. I know how to deploy containers. You can try deploying their service first, and that might fix it. And then you have fixed an outage in less time with less people, and they owe you one. And it's so nice. And I've also done that. It's great. Containers also bring along a strength if you don't have a production environment that you want to run in, like testing environments. Because what are testing environments if not spaces where ephemeral things happen that then get torn down and never speak of again? If you are working on a desktop application where your production environment is someone else's computer, you can run different versions of your application in containers, send the log output to a centralized database, and then tear down those containers, and as you clean up your testing environment. It's really nice. This also makes it way easier to fix customer bugs. You know, when customers write in and they're like, your app broke my stuff, and then you don't download anything to make your environment match theirs, and you go, can't repro, and then you close it. Well, now you can repro, and it doesn't have to be on your laptop. It can be on a server, and then you can fix those bugs. Try it against different operating systems, different releases of your code, different libraries. I mean, it really opens up the possibilities to making testing easier. So all I'm saying is that if you have somewhere in your architecture where you are running ephemeral, stateless processes, you can strengthen them with containers, and I encourage you to do so. Now, if containers have strengths, it makes sense that they would also have weaknesses. So many. And if container strengths lie in disposable, ephemeral things, then it makes sense that their weaknesses would be in things that keep their shape, that are moldable. And by that I mean stateful apps. And usually, when people talk about stateful apps with containers, they want to talk about databases. They're like, oh yeah, I saw a Container 101 talk, and now I'm going to containerize all my databases. Look forward to that blog post, Hacker News. And when they tell me this, I respond, are you Google? And that tends to hurt some feelings. Because what they hear is, are you a success? Are you a household name? Have you had a lot of lawsuits lately? But what I'm actually saying is, are you routing billions of requests to thousands of databases across dozens of data centers per second? Usually, the answer is no. And you don't have to containerize databases if the answer is no. But I totally understand why people want to containerize their databases, especially if you're working on-prem, on hardware. It can provide you faster provisioning, more stability, faster recovery times. If you are a database team and you're running on hardware, and a dev team comes to you and they say, we want to roll out this new service, we need a new database, you may have to order that hardware, wait for it to come in, get racked, provisioned, apply the schema, and you're going to want to be doing that over several environments, right? That could take months. That slows down velocity, that creates way more friction. I totally understand why people want to just spin up a containerized database right on the spot. I get it. But you can get all of this with a cloud provider and some tooling. And when I tell that to people, they go, do you have any idea how much that would cost? My God, man. Okay, sure. So you think that the cloud is going to cost less than hiring and training your own database team to research and create your own solution. Okay, because you're going to be dealing with a lot of data. And you have to make sure you are handling that data properly, that you're archiving it properly, that you're securing it properly. And you really want to do that in-house instead of just trust someone whose job it is to do that for you. But yeah, people do. And usually when they do it, they go about it in two main ways. So let's talk about those two main ways. The first way is they run a bunch of containerized database instances that are backed by some sort of network storage where they actually store their data like Ceph. And if one of those instances goes down, everyone's fine. It's cool. And then the instance comes back up, gets its state from something like etcd, and it keeps sending over data, and that's great, except eventually you will be network bound. And if you find yourself putting fiber down, dedicated fiber for your databases, you might as well just go to the cloud. So what's the second way people do it? Well, the second way people do it is they run containerized database instances, and the containerized databases save their data on the host through mounted volumes. And then, if you lose an instance, the data stays put. Now what? Well, one way you could go about it is you can just regenerate that database instance right in place where the data was. And if you recall when I say that I ran Dockerized Cassandra clusters, this is what we did. From the outside, it looked like any other Cassandra cluster running one instance per host. And yeah, we got to say that we ran Dockerized Cassandra clusters, and yeah, containerizing the JVM made it a little easier to deploy and upgrade, but at the end of the day, we weren't saving on hardware, we had to write a bunch of support tooling, and did it really get us anything except sounding good on our resumes? I mean, it does sound really cool on a resume, but no. Another way you can go about it is that instance goes away. Well, then you spawn the database instance somewhere else, but you still have that data that you have to move to that instance, and once again, you're network bound. But So if you're going to containerize your databases, my one piece of advice is keep it small. Sure, I totally understand where you order hardware for a production database, but the team wants to get going right now, so you spin them up a containerized test database in the meantime before you migrate to production. That's totally cool. Or maybe you have a lightweight assets database where if it goes down, the site just looks kind of ugly. Fine. But don't store your 16 terabyte customer account in a container. You will be very sad. Once again, use a cloud provider. I was looking at their offerings, because again, I'm not a big cloud person, and both AWS and Google Cloud have automatic failover, scalable databases, RAID replicas, and multi-regions. And Azure is not that far behind. They just have manual failovers. So seriously, consider going to the cloud. It will save you a bunch of time and hardship. and all you're going to get out at the end of the day is a blog post anyway. So this brings us to our third lesson out of 4, which is containers need friends. So often, people are looking at containers and they're just like, oh yeah, we're going to do containers. We're just going to rub some containers on that. Looking at containers now. Brad's cool website thing, we're going to do containers now. But it's never just containers. It isn't. Containers these days are a vast ecosystem of vendor solutions that you need to research and integrate with your infrastructure. And there are questions you need to ask yourself. Things like your dev setup. How are you going to build those tarballs? You could use Docker. It's pretty much primed for dev setups, but you don't have to use Docker and prod. Are you going to run your containers with Docker and prod? You should research that. Orchestration. How are you going to make sure that an app needing X amount of CPU time and X amount of memory actually lives somewhere where it has access to those things? How are you going to manage your resources? Cluster management. How are you going to handle failovers or health checks? Are you going to organize your clusters in certain ways where they run different kinds of applications with maybe different SLOs? You should think about that. And last but not least, networking. Now that you have a bunch of containerized services running, how will you handle both internal and external routing? How will you handle access control? Can all those services just talk to each other now, free of charge? How will you handle service discovery? How does a container running here find a service running over here? You need to research that. And just to give you an idea of what it looks like out there, this is just a handful of projects that handles networking in Kubernetes. And they don't all do the same thing. And you will need time to try things out. See if it works for you. What is the rate of adoption? Are people actively contributing to it? Is it backed by companies that you trust? Does it have a sense of maturity? Do you already know engineers working on the project? Are your engineers already working on the project? Is it written in a language that your engineers know so you can contribute patches upstream if need be? You need to take a look at those things, and you're going to need time to fail and experiment. But let's say you put in the work and now you have containers. Good job. Now you need to integrate it with your already existing infrastructure. For example, deployment. How are you going to deploy your services to your container platform? Are you going to use the same tooling as you have currently? Do you need to build out new tooling? How are you going to maintain 2 parallel deployment systems? And if one breaks, which one takes precedence to getting fixed? Monitoring. What new data points or metrics do you need to determine if a container or a container platform is healthy? Does your current tooling support that? Do you need to buy new tooling or make your own? Do you have to train people on it? Provisioning. How are you going to provision the hosts underneath your container platform? What changes do you need to make to your base images? And what is going to take precedence when hardware comes in? The new container platform or a database? And how are you going to make sure that you are growing at capacity properly as the container platform grows and more people migrate to it? And last but certainly not least, debugging. Now that you have added at least one, if not multiple layers of abstraction to your production environment, how are you going to be able to diagnose when things fix? And how are you going to empower the users running services on your platform to debug their own services? For example, carting logs off to a centralized location and then training people on how to use that. And because you're going to be researching and integrating and trying and failing, you are looking at a gradual rollout to both build this platform and migrate people to it. And in my experience, it's going to take you about a year to get there. And when I say a year to get a container platform, I mean you have kind of a container platform and it has one service running on it. And that's it. A year to get there. And more often than not, if you are containerizing already existing systems, it's not going to be an endpoint where everything is containerized. It's going to be a hybrid solution where some of your things are in containers and then some of them continue to run the way they've always run. And you need to understand what your actual goal is and set your expectations accordingly. So it doesn't feel like failure, it's just where you knew you were getting to in the first place. Now our last lesson is the most important one. You can ignore everything I've said up at this point. You can be like, whatever, Alice, I'm going to containerize databases on my phone. I don't even care. Kubernetes in the App Store, done, okay? Like, no. If you want to do that, fine, and tell me about it. But also, do not ignore this last lesson, which is containers need headcount. So often, a conversation behind closed doors goes a little something like this. Someone says, we need containers. And then someone else, they're both wearing suits, says, let's give it to ops. After all, ops already owns inventory and provisioning, configuration management, networking, deployment tooling, monitoring, incident response, maybe your databases, maybe security. Let's just throw containers on top of that. Because containers are like running Jenkins, right? It's like a new Jenkins. No, it's not like a new Jenkins. Deploying a container platform is like building a brand new data center in a town no one has ever been to, using hardware no one's ever heard of, in software no one's ever touched. It is a completely new venture. And so you need a completely new team. And you need to hire for that team. And when you are hiring that team, there are a few skills that you should be looking out for to make sure that you get the right people in the right mix. You're going to need someone who knows operations, preferably someone who knows operations at your company. And yes, this means you can take someone from ops and put them on your new team, but then you have to backfill them on ops, okay? You're not getting that by me. You need someone who understands where the skeletons are buried and the snowflakes are running, because the hope is that eventually those things will be containerized and moved to your new platform. You need someone who understands deployments, both at your company, but also the greater landscape. Who's using what these days, and what new technologies can you adopt to make it work for you? You need someone who can write tooling, because even after you've done all that research and cherry-picked all your vendor solutions, you're still going to need to glue them together. You're still probably going to have to write your own support tooling, and you're still going to have to integrate it with your already existing tooling, and you're going to need someone to write that for you. You're going to need someone who understands monitoring, who understands the kind of metrics and data points that you want to be looking at to make sure your container platform is healthy. You know when it's like, a lazy Friday afternoon, and someone in Slack says, I think something is broken, but I don't know if it is. And then 5 seconds later, someone else has dropped in this brand new dashboard they just made showing, yes, the thing actually is broken. You want that person. That's the person you want on your team. You also want someone who understands the kernel, who can, for example, debug a kernel crash or understand lower level systems, who can put up with the Linux kernel mailing list, because you are going to see really odd interactions between your containers, your kernel space, and your applications, and you're going to need someone who can wade through the spaces in between and understand them. You're going to need someone, likely someones, who understand networking and who can make solid decisions for your container platform, because you are adding a new layer of abstraction, and there are a few schools of thought on how to roll it out, and you're going to need people who can make the right decision for you and also debug it when it breaks. You're going to need someone who understands security, specifically container security. Containers have a bad rap when it comes to security, but they have come a long ways. And you need someone who is up in the know on the best practices and who knows what containers come with out of the box and what they don't, and who has that passion and who can make them a first-class citizen, because so often when we are rolling out a container platform or a new platform in general, security is this very last thing right before the finish line where you check it off and you're like, okay, we did it. It really needs to be up here. When people are saying we need containers, security has to be in that room helping them make that decision. You need someone who can aid in internal adoption of your new platform. You need someone who has already established a relationship in your company, who can go over to the other teams and go, that's a nice roadmap you've got there. That would be a real shame if, oops, it fell. You know what you should do instead is containerize your applications, migrate them to our beta platform, watch them break repeatedly, and then tell us what's wrong. Thanks, see you later. You need someone that can do that. Because if you don't get those beta users on your platform, it's not going to go up. It's not going to catch steam. It's not going to go anywhere. Because you need someone to find the bugs. You need those early adoptions, and you need someone that can foster that early adoption and grease those wheels and get those people moved over. And last but not least, you need a project manager. Someone who can keep the team on track, someone who can keep the roadmap on track, someone who can boost morale. And it doesn't have to be a project manager, it can also be a product manager. PMs in either form are not just for user-facing products. Infrastructure projects need someone who's on top of them, who, when something fails, because it's gonna fail, says, don't worry, we padded the roadmap, try something else, it's gonna be okay, buck up. And then they go and have those hard conversations about where you are on the roadmap and why. You need someone who could keep you on track because we're looking at, again, at least a year-long rollout, and then you're gonna keep on working on it and iterating it over time. So you need to hire a vast amount of skill sets. Now, each one of these skills does not have to be one person, but they also can't be all together one person. You need a team, and ideally it should be between 6 to 8 people. At the very least, it should be 4 people, because eventually the team building out the platform is going to be on call for it. And an on-call of less than 4 people is, in my opinion, untenable. Do not do that to them. They will burn out. Your platform will plummet into the sea. And just make sure you have at least 4 people, but preferably 6 to 8. And most importantly, you need to empower them to succeed. They need to have support from the top down that what they're doing is right and they have space to do it. Because they're gonna need to experiment, they're gonna need permission to kind of muss up other people's roadmaps so they get them migrated over. They're gonna need accounts on cloud providers so they can test things or choose which cloud provider you need. They're gonna need the space and support to do that. They're gonna need that upper management backing in the room. So today we took a nice hard look at containers and what it means to actually run them in prod. We talked about their strengths, which lie in stateless applications, those ephemeral, disposable processes that don't even have to be in prod, they can also be in testing environments. We talked about their weaknesses, aka databases and all sorts of stateful apps, and how you should probably just go to the cloud. We talked about how it's never just containers and that rolling out a container platform these days is a vast ecosystem of vendor solutions that you need to wade through and choose. And we talked about how you need to hire a team with a certain amount of skill sets in order to make sure that rolling out this platform is a success. But at the end of the day, does this really answer the question you came here with, which is, should we run containers in prod? Well, I don't know. There's no one way to choose, but there are some indicators. For example, do you have stateless services? Do you have a large, heterogeneous platform that you want to bring more in line? Do you have the time, the money, the people, the org support to try this? Then sure, yeah, try containers. It'll be fun. On the other hand, if you have a monolithic app with very few support services, if your databases have nicknames, if you have a small team with no org support, if you're like, we want to do containers, and the company is like, well, it's you and her, and you already both work here, so congratulations. Or if you just want to do it to spite me, maybe don't try containers. Unless it's the last one. If you want to roll out containers just to spite me, please do it, and please live tweet it. I would love that. At the end of the day, a nice litmus test for whether or not you should be using containers is, do you want containers or a blog post? If you are making a list of reasons for why you want to roll out containers, and reason number 2 is, it would be rad, don't do it. It's not worth it. There are so many other tested legacy solutions with larger adoption, better support, more stable systems that you can use besides containers. Containers are just a tool, and if they are not actually solving the problem you are trying to solve, don't use them, because guess what? Spoiler alert, it's okay not to use containers. It is. You don't have to use them. It's fine. I've given you permission. But if you do decide to use containers, just know that they're a little tricky. But if you have a good team behind you and you remember to have fun, you will get them in the end. Thank you very much. That's all I've got. How much time we got? We have 2 minutes. Any questions? People taking photos? Good. Thank you. All right, well, I will be around. It was really nice being here. Thank you for having me. Oh, we do have a question. We have one question.
If people, after all this, really do think they want to roll out containers,
Yeah.
what's the first, or at least one of the early things they should do so that it isn't terrible?
So the question was, if people actually do want to run containers after I've crushed all their dreams, what is the first thing that they can do to make sure it's not terrible? My answer would be engage ops. If you are not already in ops, talk to ops to make sure that they have the bandwidth to eventually own all the mistakes you're going to make if you're a developer. And in addition to that, get that top-down buy-in so that when you come to them 6 months from now and you say, guess what, the data center is on fire and we blew a lot of money, they're like, that's okay, I said yes to this. You need to have support behind you. You can't just make it a you operation because that's going to burn out at least you, if not the whole thing. Awesome. Okay, well, thank you very much.